All right, so today we're going to do some INAV troubleshooting. We troubleshoot some navigation modes. We've got some optical flow sensor stuff we're going to be looking at and just some other general things. So the first one up here is from Matt, and he has a Cine Whoop that he's trying to get to be more stable indoors and outdoors. So this is the indoor flight version here. I'm just going to let this roll. So just looking at this, looks like he moves back and forth. And when it settles into an area, you can see it starts to shake back and forth. And it almost looks like it starts to build an oscillation there. So we see that oscillation on the y-axis. We see that oscillation on the pitch axis as well. The root cause on both axes, though, is pretty clear. When you look at what, this D term right here is really the issue. That is a D term resonance. So you're hitting the resonance frequency with the quadcopter and the D term PID. So going back to his video right here, we're looking at this gain right here. And I need to correct myself on this quad. It looks like that the pitch axis is the Y in this scenario. So that might have to do with the flight controller orientation, I believe. Now, as an alternative to increasing this gain here, the I gain, which you can see kind of through the screen here, you can also increase this P gain for the position estimator, because if you think about how that works, so they're kind of the same thing. If you increase this, that's like increasing the I gain of the velocity estimator or vice versa. Now, the other thing we can look at is the sensor accuracy for the optical flow sensors. Now flipping those thicknesses around. So if I go like this, and now I made the other two traces, you can see when he inputs a stick entry, how it sees it going to the left a little bit, and then it pushes it to the right. So that was right here. See how right here it sees it going to the left, and then it sees it going pushing to the right. So that is working accurately. It looks like it's tracking it pretty well. So in conclusion of that one, that's how you can kind of get a sense, is your optical flow sensor reading things well? And that comes into play when you're outside, because I think people want these optical flow sensors to work at a much higher altitude than they do. Most optical flow sensors only work like 2 meters. So now let's take a look at what Matt is getting for the outdoor on the same quad, same PID, same everything. It looks like just in the driveway. But it does look like right there, it's kind of drifting off. See that? And then he inputs a move, and then right here, it kind of drifts back a little bit. And you can see right here, look in the video, look at the garage in the video, we have this drift going to the right. And you can see again, that low I or low P gain or combination, you can either raise either one of these, how the target velocity versus the actual velocity is not aligned. You need to, I would be increasing this gain, because this is just at a 10. This is pretty high. You can only go up to, well, you can go up to 255 on this. And side tip, if you are outside and you have an optical flow sensor that goes up higher, you can see you're gonna have to adjust this variable. This is the INAV max surface altitude. The default is 2 meters. So you're going to have to raise that up, or you'll be cutting yourself short. You can see this is in centimeters. There is a couple other variables that people have optical flow sensors should be aware of. There's this optical flow scale, and there's a scalar value here. And you can see the default is 10.5. So that should just push that sensor's sensitivity up in general. There is a variable for the INAV weight of the XY flow, optical flow, for the P and the velocity reading back from that optical flow sensor. So these may come into play, but I would adjust the primary PIDs first in the estimators. Again, the XY estimators I talked about a couple times. And if you are using an optical flow sensor or lighter, and you're dealing with any elevation variances that you want to deal with after making sure your Z position and velocity PIDs are in line and not the issue, you can also make sure you're aware of that there's an INAV Z surface P and V here as well. So that is that. So they say in tuning, it is a iterative process. So you would go ahead and make those adjustments that I recommended, or you're seeing that you need to recommend, and fly it and see how it goes. If you found that video helpful and you want more detailed information, check out the link in the video description for the full version of the video, which is up on my Patreon. If you do have any questions, don't hesitate to drop them down in the comments as well. Thanks everybody, and I hope this helped.